Assalamu alaikum. So today we are working on a digit MNIST, a machine learning project. So in the first cell, we are only just setting up the environment. NumPy for arrays and maths, a matplotlib.py plot. We imported this as we are using this for quick plots, Keras as the deep learning framework, MNIST for ready to use 28 by 28 digit images, the sequential API to stack layers and the key layer, con2d to extract image futures, maxpool2d to downsample, flatten to turn future maps into a vector, dense for classification, and dropout to reduce overfitting. So here there is no training yet. This simply loads the tool we will use next in the uh, project and in the next code. So in the next cell, here we load the MNIST dataset using MNIST load data, which returns training and test splits. Xtrain, Xtest are 28 by 28 grayscale digit images as NumPy arrays, and Ytrain, Ytest are their labels from 0 to 9. The print like simply verifies the shapes, typically 60,000 28 for Xtrain, 60,000 for Ytrain, 10,000 28 for Xtest, and 10,000 for Ytest. So here we got the shape function we used for checking the shape of our train and test datasets. So here we got the 60,000 28 60,000, 10,000 28 and 10,000. Okay, so in the next paragraph or in the next cell, we will visualize any training image by its index. plt imshow xtrain I cmap binary and renders the 28 by 28 pixel digit in a black on white style. The binary color map inverts MNIST so it looks like an ink on a paper, like this. You see, ink on a paper. Okay, look. And plt.title Ytrain I places the true label on top for quick reference. Here we see this one. I'm sorry, this one, this one, title. And plt.show pops the figure to screen simple and perfect for checking samples before training. So in the next cell we are using a for loop. So in this we're just looping from 0 to 9 to preview the first 10 training samples. Each pass calls plot input image when displays the digit image and its true label on top, so we can quickly sanity check that MNIST loaded correctly and the labels match what we see. Okay, so this step does not change any data. It simply helps us visually confirm everything looks right before we start building and training the model. So here we can see we have got the images of 0 to 9. Okay, that's fine. Now in the next cell we have used the load MNIST set by 22 multiplied by 5 grid and show one sample for each class 0 to 9. Look, we are using 2 multiplied by 5 grid sample and we are using 0 to 9 in one image. We're combining this all in one image. So here we are preparing, and first we normalize images to 01 with as type np float 255. So training is suitable or stable. The training is stable. Okay, and then we add a channel dimensional via np.expand dimensions minus 1, turning shapes from 60,028 to 28 into 60,028 to 1. Here you see we have used minus 1. Okay, and because because con 2D expects r multiplied by g multiplied by w, r g b, r multiplied by g multiplied by b. Finally we convert labels to one hot vectors using to categorical. Look, we used a categorical, so that import our dataset or the keras utilist which we exported. We are saying here that convert this all dataset into categorical. Okay, and next we will build a compact CNN for MNIST, start a sequential model, add a con 2D 32 3 multiplied by 3 ReLU. Okay, we're using a ReLU activation function. So and learn low level edges and strokes 28 1, a grayscale input, then max pole 2D 2 multiplied by 2 to shrink spatial size and keep the strongest features. Stack a deeper comp 2D for richer patterns, loops corners, followed by another max pole 2D 2 multiplied by 2. Look here, 2 multiplied by 2 max pole 2D. Okay, and we have used a flatten, converts the future maps to a vector, and we are also using a dropout here. I have told you already that dropout is used to reduce the overfitting, and then at last we are using this function softmax, and output class probabilities from 0 to 9, clean, fast, and a solid baseline for high accuracy. We will expect high accuracy after using the softmax activation function, and dropout is used to reduce the overfitting. Here we use a model.summary. Model.summary is used to take the summary of a whole code or a data set. Here we have layers, output shape, and a para mean parameters. Okay, look, we have total parameters 34 to 826, trainable parameters and non-trainable parameters. So here we have model.compile, and we are on this cell. In this cell we are adding we are wiring up a training here. Model.compile compile. Okay, so optimizer Adam loss keras matrix accuracy, cross entropy is used also in this. So it tells keras to train with Adam, an adaptive optimizer that tunes learning rates per weight, and it's a great default. Measure errors with a categorical cross entropy, the right choice because we want hot encoded labels with the categorical, comparing the model softmax probabilities to the true class distribution, and report accuracy during training validation. So here we are just compile using functions and for checking the accuracy, and we have compiled our model. So here we are using callbacks. So we are adding smart training helpers. Early stopping watches accuracy and with min delta 0.01, and patience is equal to 4. It stops training if validation accuracy does not improve by at least 1 percentage point for 4 epochs. It also saves times and prevents overfitting. While model checkpoint saves only the best performing weights to best model keras, like this. Whenever well accuracy hits a new high, both are wrapped in CB. Here we have wrapped ES and NC in the CB. Alright, and here we have used his function. We are kicking off training. His is equal to model.fit. So X10, Y10 epochs, we have used 5 epochs. Validation split, we have used validation split 0.3, and callbacks, we have callbacks. So we have call these functions or a variable, we have made a CB, named CB. We are setting automatically holding out 30% of its for validation. The callback you set, we have set a callback here. Um, Early stopping and model checkpoint will stop early. 1% no gain for 4 epochs and save the best weight to best model dot keras. The return value is a history object with per epoch matrix. So here we have used a model underscore s. We are restoring the best model for disk keras dot model dot load underscore model. Um so it reconstructs the full architecture and uh, just loading the model that we have used. This is the model dot keras. It only loaded and leading makes this a raw string, so windows backslashes don't break. Here window backslashes. So this also matches file with model checkpoint. If you had saved only weights, you did instead rebuild the same architecture and call load weights. So at last we have a score, and we have printed the function the model of accuracy to check the score and accuracy. So we have got a 0.98 accuracy. So here we are finalizing the results. Model underscore s evaluates, runs the model once over the unseen test set in fairest mode, and returns a list by default because we compiled with matrix accuracy. Therefore score 1 is the accuracy and your print shows it as a decimal 0.9912 for a cleaner readout. You can do print test accuracy. We have done here. We have also used a pygame to check the I have made an interface, a small interface. Here the code is same like this, just we have used and to make a front end. So let's run this code. Oh, I'm sorry. So here we have run Python file in terminal. Just wait a second. Look, we have here I have got this an interface, and if I write a 1 here, so it's 1. If I add a 2 here, so it's 2, 3, 4, 5, 6, 7, 8, 9, and we have also 0. So look, this it's awesome. Thank you so much for watching my video, and click the subscribe button. Thank you so much. Allah Hafiz.